Welcome. Now discuss Nd-YAG laser. So that means neodymium, yttrium, aluminum, garnet laser. So now discuss characteristics of Nd-YAG laser. So type of laser is doped insulator laser. That means a solid state laser. Active medium, yttrium, aluminum, garnet, Y3Al5O12. Active center, neodymium. And pumping method, optical pumping. And pumping source is a xenon flash lamp. So optical resonator. So ends of the rods polished with a silver and two mirrors. One of them it's totally reflecting and the other is partially reflecting. And power output 2 into 10 power 4 watts. So nature of output pulsed and wavelength emitted 1.064 micrometer. See, so the Nd-YAG laser is a doped insulator laser. So it is a 4-level system in which the active medium is taken in the form of a crystal. So here the crystal is intensely doped during its growth. So those type of laser has number of energy levels with the same energy. So the laser is used to generate a high power intensity. And the principle of Nd-YAG laser is the term doped insulator laser is refers to the active medium yttrium, aluminum, garnet doped with neodymium. So the neodymium ion has many energy levels due to the optical pumping. These ions rise to excited levels. So during the transition from metastable state to even state, the laser beam of wavelength 1.064 micrometer is emitted. I now discuss about constructions. So the active medium is made as a rod, so which has yttrium, aluminum, garnet doped with rare earth material ion neodymium. So the neodymium ions normally occupies the yttrium ions and provides the energy levels for both lasing transition and pumping. So this rod is placed inside the high reflecting elliptical cavity. A close optical pumping is made by placing the xenon flash lamp nearby the laser rod. So in such a way so that most of the radiation from the flash tube passing through the laser rod due to the elliptical cavity. So the flash tube may switch on and controlled with the help of capacitor. So the discharge capacitors is initiated using the high voltage sources. So the optical resonator is formed by grinding the ends of the rods and coated with a silver accompanied by two mirrors. So one is 100% reflecting and the other is a positive reflecting. So which is included to increase the efficiency of the output beam. So working of Nd-YAG laser. So the xenon flash lamp is switched on and light is allowed to fall on the laser rod. So the intense white light exits the neodymium ions from the ground state to various energy levels above E2. So hence the atoms rise to group of higher energy level in E3. So as I illustrated the energy level diagram. So E1, E2, E3 is the various energy levels of Nd3 place laser. So E4 is the metastable state and E0 is the ground state of energy level. So from these energy levels, the ions make non-radioactive decay and it's gathered in a state called as a metastable state. So until the population inversion is achieved. So once the population inversion is achieved, the stimulated emission builds up rapidly. So hence pulsed from form of laser beam of wavelength 1.064 micrometer is emitted during the transition from E4 to E1 lower. energy level. So a large amount of heat is produced by the flash tube during the working. So hence cooling arrangement is made either blowing air or circulating water over the crystal. And applications of Nd-YAG laser. So it is used in transmitting signals to longer distances, and it is used in a long haul communication system, also used in the endoscopic applications. It plays a vital role in remote sensing applications. For continuous laser beam, the xenon flash lamp may be replaced with the quartz halogen lamps. Thank you. We discuss in next video.